Welcome to the 12.1.2 video lesson. Today we're going to start with our warm-up here. It says fill in the blanks in order to factor and solve the problem below. Factoring was covered in our last lesson, so hopefully you remember how to write these parentheses which multiply together and how to fill in these blanks. What might also help you is a t-table. So if you want to make a t-table, that will certainly help you. I'm not going to tell you what to put into that t-table yet, but if you want to pause the video and get started on this, we'll come back together in just a second to show you how to do this. Alright, looking at this problem, it says x squared plus 4x minus 12 equals 0. If you are factoring this with this set of parentheses, remember you need to look at factors. I'm using my mouse here today, so it's going to take me a second to write. But you're looking at factors of negative 12, and you want them to have a sum of 4. Keep in mind that there's no a value out in front of this x squared, so we're simply looking at factors of negative 12 whose sum is a positive 4. Remember that when looking to factor, you should always start with the first set, 1 and 12. I like to write these as positive and then come back and worry about the negatives later. But we have 1 and 12, 2 and 6, and obviously 3 and 4. And after 3, we're back to 4, so we should be good. If we're looking at which number here needs to be negative, if I want the sum to be positive, then the smaller number needs to be negative. And I think as you go through this pretty quickly, you know that negative 2 plus 6 gives us a sum of 4. So those are the factors that we're looking at filling in here. We've got a minus already in this second set of parentheses, so I'm going to put my negative 2 there. This 2 is negative. And then I have positive 6. Remember, if you want to multiply this out and FOIL it, you could certainly do that to check, but I think if you multiply this out, you'll get exactly what we started with. Moving forward here, to use the zero product problem, or the zero product property, and actually solve this problem, we have that x plus 6 times x minus 2 equals 0. And the zero product property says that one of these two binomials has to equal 0 in order for the whole entire thing to equal 0. So if I start with the first one, when x plus 6 is 0, it must be true that, well, if I subtract 6 from both sides, it must be true that x is negative 6. And remember, if you take this answer, if you take this negative 6 for x, and you plug it back into x here, it would make sense that negative 6 plus 6 is 0, and then anything times 0 equals 0. So this checks out. My first answer here is negative 6. On the other hand, if x minus 2 is equal to 0, well, if x minus 2 is 0, then I'm going to add 2 to both sides, and I will get that x equals positive 2. And again, if you take positive 2 and you substitute this back into your factoring, so if you put that 2 in place of x, 2 minus 2 is 0, and anything times 0 is 0. Likewise, it should make sense that if you also substitute these answers into the original problem up here, if you substitute them into there, they will also equal 0. So final answer here, x equals negative 6 and x equals 2. Moving forward today, do make sure that you hand in your homework, which was that factoring review worksheet. That covered all of the different types of factoring, including what you saw in the warm-up. So do make sure that you hand that in today before we get too far here. To look at our lesson today, 12.1.2, the lesson objective is to solve quadratic equations by completing the square. Now, depending on what school you were previously at or who you had as a teacher, maybe you learned completing the square in Algebra 1, maybe you didn't. But the whole goal of completing the square is to do exactly what factoring does, only in a different method. So maybe with things that are less factorable, or some people prefer completing the square. We're going to be looking at that today. And then we're going to be applying it to our circle equations in our following lesson tomorrow. So we're going to do completing the square. I have two examples for us. We're basically going to take these down as notes. The best way to see completing the square or to learn it is normally to see someone else doing it, because this method is just a little bit unorthodox if you had to try to discover it on your own. You're hopefully going to get some homework time today in class. And if you're seeing me teach this in person, you're also probably going to get the write a problem activity. If you are just watching this video, you're not going to do that last activity. So if I grab my marker here, if you're watching the video, you're not going to do this third activity. But moving into our examples today, you're going to want your set of notes for how we're going to do this. For today, the first question I have for you is, what were the solutions to our warm-up? So think back to the warm-up. Yes, we factored this, but the solutions, I believe, were x equals, no, I have to look back, were x equals -6 and x equals 2. X equals -6 and x equals 2. And I kind of already hinted at this with the lesson objective today, but completing the square is just another method for solving quadratic equations. So we're going to take this same exact thing that we had in the warm-up, the same equation, and I'm going to show you how to solve this in a different way, something called completing the square. Keep in mind we already know the answers, so if we are doing this correctly, we should arrive at these same solutions. Okay, when we complete the square, the first thing that we do is we actually get rid of the C value. And this is a little bit counterintuitive, because normally in factoring you need that C value to find the factors of -12. But here we're going to get rid of that -12. We're just going to add 12. We're going to add 12 on both sides. And the reason that we're getting rid of 12 is that we're going to try to change this into a perfect square binomial. And if you don't know what a perfect square binomial is, you'll see this as we go. But we need to get rid of this C value of 12 because we don't know the square root of 12, right? That's not a perfect square. And we're going to leave a blank in its space, meaning that when I do -12 and +12 on both sides, I get an equation like this down here. I get x squared plus 4x, and then a blank equals 12. Now my next step here that I need to do is I need to find half of b squared. And what we're doing here is we're creating the perfect square, which we didn't have before, right? Nobody knows the square root of 12, at least not off the top of their head. And what we're going to do now, I'll just grab a blue here. We're going to find the half of b. My b value was 4. So I'm going to do half of b, right? Half of 4 is 2. And I'm going to square it. Half of 4 is 2, and I'm going to square it. So that is, well, that's just 4 again. Now that's not always going to work out, right? It only works out with 4. But I'm going to take half of this b value, and I'm going to square it. And that's 4. And again, if you don't know why, it's because we're trying to make this perfect square binomial something that we know the square root of. So I'm going to take this 4, and I'm going to add it to both sides. If you want to, you could just add it right here. Obviously, I have this written here, so I'm just going to add it down here. But I'm going to add 4. I'm going to add 4 to both sides. Keep in mind that we have to do this on both sides of the equation in order to keep it equal. Just like we added 12 to both sides here, we need to add 4 to both sides here. Now what this gives me is something like x squared plus 4x plus 4 equals 16. And this does a couple things that are kind of neat. Because this is now a perfect square, we can factor this and we can solve it. And if you don't know how to factor this using completing the square, well, if I look at x squared plus 4x plus 4, I could do my t-table, right? I could look at factors of 4, which add up to 4, but that's really just 2 and 2. So I could really write this two different ways. And I'm going to change to a different color here, sorry. I'm going to grab pink. But I could do this two different ways. I could write out x plus 2 times x plus 2. And again, the reason they're both x plus 2 is because 2 times 2 is 4, and 2 plus 2 equals 4 in the middle, right? I'm looking for factors with the correct sum. But honestly, I don't have to even write out all this. What I could do instead is I could write this as x plus 2 squared. And this will always work. You can always write this as x plus 2 squared as long as you are taking half of b and you're squaring it. It throws that 4 as our third term here, which is a perfect square. And we know the square root of 4 is 2, right? 2 times 2 gives me that 4, and it also happens to add to 4 right here. So I will always get this perfect square binomial. This is why we call this completing the square. You've made this square binomial equal to 16. Now, it happens to be that in some problems, this is much easier because we have the 16 on this side as well. And remember, I'm going to use the square root to solve this. So I'm going to grab another color here. I'll go back to green, but I'm going to use the square root to solve this problem rather than the zero product property. Remember back in the warm-up, I'm going to go all the way back to the warm-up. In the warm-up, we factor and then we use the zero product rule where it's equal to 0. But now it's not equal to 0 anymore. It's now equal to 16. And if I take the square root of both sides, the square root undoes my square, so these two things cancel out. I'm going to grab another color here. I'll grab red. But my square root cancels off with my square, and we have the square root of 16. Now this is probably the biggest mistake that students make when completing the square. And that's that I'm going to write x plus 2 equals, well, the square root of 16 is 4. And this would give me one answer, right? I could subtract 2 from both sides, and this would give me an answer. But I would be missing the other answer as well. And the other answer is the fact that there are actually two numbers whose square root, which are the square root of 16. 4 times 4 is 16, but we also know that negative 4 times negative 4 is 16. So you have to use both the positive and the negative square root of 16, which is 4 and negative 4. Now it's still equal to x minus 2, which I have here, but when we are completing the square, we need to break these into two separate problems which we are solving. Now when I go back and I subtract 2 on both sides, I do my little bit of mental math, just like when I do factoring. I'll subtract 2 on both sides. 4 minus 2 obviously gives me x equals 2. There's my first solution. And then the other one here, when I subtract 2, negative 4 minus 2 is negative 6. And again, these should perfectly match my previous solutions. Here, x is negative 6 and positive 2. And when I go back up, x is negative 6 and positive 2. Completing the square. Remember, completing the square is all about making this into a perfect square binomial. That's binomial which is squared so that we can use the square root to solve it rather than the zero product property. Now, here's the second example that I have for you. We're going to go through this step by step, 1, 2, 3, 4. If you want to at this point, you could certainly pause the video, give this a try on your own. Maybe just do one step, play the video, pause it, then do the next step. But go ahead and give this one a try, and then I'll show it to you in a second here. Alright, so looking at this one, step 1, I'll try to keep these color-coded. In red, I'm going to eliminate my C value. So I'm going to get rid of this 16 by adding 16 to both sides. Now you may say, well, don't we already know the square root of 16? And isn't this just x plus 4, x minus 4? Remember, this is a negative here. So we always get rid of this c value first, even if you know it's square root. But that gives me the equation x squared plus 6x. And I really like to leave a blank here because we're going to put a c value there in a second. But it equals 16. So I kind of leave this blank here, which I'm going to fill in step 2. For step 2, it says find half of b squared. Remember, half of b is this value in the middle, which just has a single x, 6x. Half of b, half of 6 would be 3. So 6 divided by 2 is 3. I'm just going to write it over here. It equals 3, and we're going to square that, right? That middle term, half of it squared. 3 squared, 3 times 3 is 9. And this is what I'm going to add to both sides in my next step. I'll try to use this same yellow. I'm going to add this to both sides. I'm going to add 9, so plus 9, and then I'm also going to add 9 over here. And at this point you can see where, okay, that 16 we had actually isn't all that important, because when I add 16 and 9, I actually get 25, and that's something that I know the square root of. I'm just going to rewrite my equation here, x squared plus 6x plus 9. And to finish this off here, it says factor and solve. Make sure you are both factoring and solving the equation at the end, getting those x solutions. When I go to factor this, again, I could make my t-table if I really wanted to, but at this point I'm looking at this 9 and I'm saying, okay, the square root of 9 is 3, right? And 3 plus 3 is 6, right? We already said that. It was half of the b value. So I could just write this as x plus 3 times x plus 3. And it still equals 25. And again, if you wanted to go through your whole t-table, you could certainly go through the t-table here and find factors of 9 which add up to be 6. Well, you just get your 3 and your 3 from the t-table. Now at this point you could start trying to think about solving it, but again, it's not equal to 0, so we're going to write this as my perfect square binomial. X plus 3 times itself is the same as x plus 3 squared. And again, if you really want to, you could certainly skip this middle step here in pink. This is just x plus 3 squared because it's always going to be a binomial times itself. When we go through and we solve it now, remember, because it's not equal to 0, we're going to take the square root of both sides, and we end up with x plus 3, right? The square root and the square cancel out, and we should know the square root of 25 is 5. I'm just going to write this, we'll go in green over here, but again, the square root and the square cancel out. The square root of 25 is 5, and on the left side we still have x plus 3. But don't forget about the second square root of 25, which is also negative 5. And on the left side we still have x plus 3. Remember, this is where we're getting our two solutions. The square root of 25 is both 5, and the square root of 25 is negative 5. When I solve this little bit, I subtract 3 from both sides, and we get answers or solutions like x equals 2, and the other one, when I subtract 3, we get x equals negative 8. You should pretty much always get two solutions here on these. because again, you're going to get a positive and a negative square root, and then you're doing the same thing to both sides. With that, your homework for today is going to be worksheet 12.1.2a. I will tell you, if you're watching this video, your homework is going to be due Wednesday. Obviously, when we come back together tomorrow, you'll have time to ask questions on this homework. Good luck.